This is Geometry Unit 6, Lesson 7, More Triangle Proof Practice. So let's take a look at this proof and see if we can figure out how to prove that AM is congruent to OM. This is a little bit more complicated because we have a lot more givens here, but let's see if we can figure this out anyway. So our goal is to get AM congruent to OM. So AM is here and OM is there. So our goal is to get those two sides congruent. Now, by the way we've been doing this, what we've been using is using CP/CTC once we've proved a pair of triangles congruent. So let's see if we can apply that here. Let's figure out what triangles we probably want to prove congruent. Well, those two sides are part of the triangles IAM and NOM, or triangle IOM and NAOM. So you can do either one. I'm going to do the two small triangles. So I'm going to draw them separately over here so I can see exactly what I have and exactly what I need. All right, so here is the triangle IAM. It looks something like this. This is IAM. And since I want this to correspond, I'm going to draw exactly the same way, except I'm going to label it with the other triangle that I'm trying to get and get the corresponding parts. All right, so I should correspond to N, A should correspond to O, and M should be M. All right, so that gives me a goal of where I want to be. So what I'm trying to get is to get these two sides, AM and OM, congruent. That's my goal. All right, so let's take a look at our information that we have here. We have triangle DIN here at the top, where DI is congruent to DN. So these two sides are congruent. And I have DI is perpendicular to IM, and DN is perpendicular to NM. Okay, we know perpendiculars make right angles. So let's see what right angles we would have in the picture. DI is perpendicular to IM. Here's DI, here's IM. And DN and NM. DN and NM would be perpendicular right there. So there's my right angles there. Okay, then I have IAON as a line where IO, see if I can mark it like this, here is congruent to AN here. Okay, so I've got a lot of information there. Let's see if I can figure out what I have to do this. Well, let's start with an easy part. We know that to get a side here, we have this whole piece, but we only want this little piece. So probably what are we going to have to do that? Well, we probably need to subtract something. So what are we going to subtract from? Well, probably IO and AN, and that came from the line IAON, so that reminds me that I'm probably going to have to subtract. Okay, so let's start with that. Go down here to my diagram and my statements and reasons. So number one, I'm going to start with IAON, where IO is congruent to AN, and that's given. Now, in order to subtract, I need another congruent quantity. So I only want IA and ON, so I have to actually subtract AO from both of those pieces. So I'm going to write that down. Put this down here. I have AO is congruent to AO. And that's by reflexive, and I did that so that I can take IO and subtract AO and AN and subtract AO, and I end up with IA is congruent to NO using subtraction on numbers 1 and 2. So I have now proved this side is congruent to this side. So there I am. Okay, so I've used this given, use this given. All right, so I've got a pair of sides. Well, let's deal with the perpendiculars. Okay, we know that makes right angles, and that's partly in the triangle that we want. So we might need those later. So let's do the right angle. So I'm going to use these two givens right here. DI is perpendicular to IM, and DN is perpendicular to NM. DI is perpendicular to IM. DN is perpendicular to NM. that's given. And then they made the right angles. Now remember, you got the whole right angle here, DIM and DNM. Those are the right angles that are congruent. Angle DIM is congruent to angle DNM because perpendicular lines form congruent right angles. So we now have that this right angle is congruent to this right angle, but do we need that entire angle? No, we don't. We only need the little part AIM. So we need this angle right here and this angle right here. But how are we going to get that piece? Well, remember that this is the whole angle and this whole angle are congruent. So if we could take this piece and this piece out, we'd be all set. All right, but in order to do that, they have to be equal. So we need to get those equal. So if I look at my given here, I have triangle DIN where DI is congruent to DN. These two sides are congruent. Well, what does that make that? Well, it makes DIN as an isosceles triangle. And what do we know about isosceles triangles? That their base angles are congruent. So that would get DIN congruent to DNI. So let's do that. All right, so the given that I'm working from was in triangle DIN. DI was congruent to DN. So that gives me a given. And from that, since in the triangle these two sides are congruent, the base angles are congruent. So I can say angle DIN is congruent to angle DNI because base angles of an isosceles triangle are congruent. Okay, and the isosceles triangle came from this. So now we have that this angle here is congruent to this angle here. So since those are congruent, I can now subtract them from the right angles. So I am going to take statement 5, DIM, and subtract 7, DIN. Take these two angles, subtract them. These two angles, subtract them. And what I end up with is angle AIM is congruent to this minus this is ONM. All right, so that's using subtraction again on numbers 5 and 7. Okay, so now what do I have? I have proved that this angle is congruent to this angle. So I have a side and an angle. All right, so now these two angles are congruent. This one and this one are congruent. We have proved that. Okay, so I'm out of givens, so there must be one more thing that I need to know. What I need to know, I need either another side or I need another angle. All right, now, do I have any way of getting the angles? Not that I see. I don't have enough information there, so I can't do this angle right here. I've already got an angle, so I'm probably not going to use side, side, side. So that leaves side, angle, side. So if I'm going to use side, angle, side, what sides do I need congruent? Well, I need IM and NM. So let me mark those on that on the original diagram. Let me do it in pink here. Here's IM and here's NM. All right, now remember, we just proved that these two angles right here were congruent by our previous step. Well, if those two angles are congruent, what does that tell me about triangle INM? Well, isn't it an isosceles triangle? Yeah. So if these two angles are congruent, that means the sides opposite them are congruent, making IM an isosceles triangle, and IM is congruent to NM. Okay, so because we proved these two angles congruent, this side and this side are also congruent. So, moving on down back here, I can say that IM is congruent to NM. Now that's the base angles theorem, it's converse, switched around. So if two angles of a triangle are congruent, the sides opposite them are congruent. Okay, so we have now proved that IM is congruent to NM. So that means the triangles are now congruent. Triangle IAM is congruent to triangle NOM by 10 side angle side. So if those triangles are congruent, are the blue lines AM and OM congruent? Yes, they are. By our 5 letters, CPCTC. So AM is congruent to OM by CPCTC. So this was many, many steps. So notice when we did this, we went one piece at a time and saw what we could prove and where we could go with this proof. Now again, if you did this in a different order, it doesn't necessarily mean you're wrong. So if you did, for example, the right angles first, that's fine. You just have to know if you have it in an orderly fashion. Make sure that you've got everything there that you're supposed to have to prove when the triangles are congruent. Okay, so that's the triangle proof practice notes. We'll be doing the homework that goes with this in class the next day. Have a good day.